So at the latter half of yesterday, we began talking about functions, which we described as pretty much being like a machine, right? You throw in an input and an output emerges from the machine. So we're just going to wrap up that conversation. I'm going to demo a slightly more complex function, but there's nothing here that we don't already know about. At the end of yesterday, we created a function that adds together the first two items of an array. So I guess let me just start by rebuilding that. We'll just comment this out for now. So we wanted to create a function. We'll call it, I don't know, the adder machine, or the adding machine, which will accept an array. So just reminding everyone about this thing here is the name of the variable. So when the input goes into the machine, into the function, this becomes the nickname for that input. I can name this whatever I want, but I decided to call it array input. Before we build the internals of the machine, let's demonstrate how we intend to use it. I would like to throw in a single array as input into this machine, into this function. And I want the output to be the sum of the first two numbers of this array. So I want the output should be 3, because that is the sum of 1 plus 2. Right? This is the last thing we did yesterday. So the way we achieved this is we said we'll make a new input, a new variable rather. I'll call it output is array input 0 plus array input 1. Recall that we also learned about arrays yesterday. So in order to grab the first item from an array, you reference the array and follow it with square brackets and a 0. That gets the first item from the array, and then array input 1 returns the second item from the array. We're going to take the sum of those two numbers and make that sum, we'll give it a variable name called output, and then we return that output, because every function always returns something, right? Like the Sneetch machine, something always goes in and something always goes out. So if we run this, we get a syntax error because unexpected keyword end, because I wrote function and it should be def. In JavaScript, it's function. So, and now we get 3. Okay, so the more complex function that I'm going to demo now is a function that returns the sum of all the numbers of an array. So this function just returns the sum of the first two numbers of the array, but I want the sum of all of them. So we could actually still call our function adding machine, because that's still a proper description for it. Just now it's going to add all the numbers. And in this case, so I'm going to wipe, well, hold on to that one second. But the output that I want should be 1 plus 2 plus 3 plus 4 plus 5, which is 15, I think. Okay, that's where we're headed. Now, I could, and this is probably what people are thinking, I could solve this problem by extending what I've done as follows. Right, this is a proper solution, right? Just because I want to add all 5 numbers doesn't really make this more complicated. I just have to add more things. But here's the catch. What I want this function to be super flexible, and I want it to work for arrays of varying sizes. So if I kept this function as is, but threw into the machine an array that only had 2 items in it, it will break because it's trying to add things that aren't there. If I added a 6th thing to this array, it wouldn't break, but the answer wouldn't be correct because it's only adding the first 5, giving me 15. But I want a function that adds all the numbers, no matter how many numbers there are inside this array. Really, the output here should have been 21. So that's the challenge. I want to make a function that is super flexible. It will add up the sum of all the numbers of an array, no matter how many items there are in the array. Does that challenge make sense? It's formidable. So let me show you how one might approach it. Now, again, there's no new concepts here. Everything I'm going to show you are concepts that you already know. It's just, the putting of all these things together. So we're going to use a loop. That's sort of where we're headed. We're going to use a loop to go through each of the numbers in the array. And as we go through each number, we're going to be adding it up. So let's put this function on a commercial break. We'll come back to it. And let's solve this problem outside of the context of a function. Sometimes it's hard to solve a complex problem as you're building the function. So what I'm going to do here is sort of solve the complex problem without the function, and then we'll plug it into the function. So let's start over. Let's make a variable called array that is going to have these 6 numbers in it, of which the sum, if we actually added all those numbers together, we would get 21. I would like to write code that will loop through this array and give me the sum of all these numbers. So I'm building this up slowly. Let's work with the fact that we know that there are 6 numbers in this array. We'll change this shortly. But because I know that there are 6 numbers in this array, I'm going to make a loop that runs 6 times, because I'm going to go through all 6 numbers inside this array. And I want to create some sort of variable that keeps track of the sum as I move through all the variables in the array. So I'm going to make a variable called sum. And I'm going to start it out as 0. We did speak about the other day how in many different algorithms where you're trying to keep track, especially of something like a sum, in many cases you end up needing a variable before the loop begins that starts at 0. The idea here is we're going to loop through this array, and as we loop through it, we're going to add the number we're up to the sum. So something like sum equals sum plus the number we're up to. Now, in order to effectively loop through an array, this is a trick we learned yesterday. We can make a variable. I'm going to call it index. And I'm going to start index out at 0 as well. The index keeps track of which index we're up to in the array. If you'll recall from yesterday, every slot inside the array is called an index. So this is, the 1 is contained within index 0, because remember arrays start at 0. The 2 is contained in index 1. The 6 is contained at index 5. So as we loop through the array, we're going to increase the index by 1. Let's put that on hold for a second. If I want to print out each of these numbers, I could say p array brackets index, and that will print out all 6 numbers. And again, the way this is working is let's follow this through. So before the loop begins, index starts out as 0, right? So when we say p array index, that's as if we say p array 0, which array 0 gives us the first item in the array, so it prints it out. We then increase index by 1, and we start the loop for the second time. Now when index is 1, when we say p array index, it's as if we say p array 1, which will give us the 2. So that's why the 2 prints out to the terminal. Then index increases by 1, so now index is 2, and we start the loop a third time. We say p array index, which is if we said p array 2, and that returns that prints out the 3. Does that make sense? How we use this index variable to help us progress through the array? We start the index variable out at 0, and we keep on increasing it by 1. And then we check each item in the array by saying array square brackets index. So we say, it's as if we say array 0, array 1, array 2, and we can effectively loop through the array. Does that make sense? That's one of the big tricks of arrays, is the ability to loop through it. And you always achieve that through an index variable like that. So now instead of printing it out, really what we want to do is say, we don't want to print these numbers out, we want to add them to our sum. So we say sum equals sum plus array index. Because before, let's follow this through. Before the loop begins, sum is 0, right? Let's keep a comment here to track which, what index is up to and which round of the loop we're up to. So let's start the loop for the first time, right? 6 times do. So sum equals sum plus array index. So since index starts out as 0, when we encounter line 9 for the first time, it's as if we say sum equals sum plus array 0. What is array 0? 1. So we say sum equals sum plus 1. So let's keep track of the sum as well. So the sum is now 1. We then get to around line 11, which increases index by 1. And now we're up to loop round 2. We start again. Sum equals sum plus array 1. What is array 1? 2. So the sum has now increased by 2, so the sum is now 3. And we increase index by 1. And we begin again. Basically, just like before, as we went through each round of the loop, we printed each of these numbers. All we're doing here is, as we go through each round of the loop, we're adding each of these numbers to our sum. Again, pointing out what I like to point out often is that talking to computers is different than talking to a human. When I talk to a human and I say, hey human, can you please add up all these numbers? What you would do is you would start with the 1, and then add 2 to it, and add 3, add 4. But what we're doing here with the computer is we're actually starting with a 0 and telling the computer, add all these numbers to your 0. That's just that's just how, when using a loop, we have to get this to work. Does this make sense? Okay, so this is, now what's really cool, well, I don't know how cool it is. Now if I added a 7th item to this array, this would not work unless I now change the loop to be 7 times, right? So this code is not we have not achieved that flexibility that I'm looking for. Because as we change the number of items in the array, we're going to have to change the number of times we run the loop accordingly. Okay. Now, let me show you, this next trick is new. This is actually a new concept. It's the one new concept we need. I want to show you a way in which I will never have to change line 9 ever again, no matter how many elements there are in this array. So I'm going to introduce this trick of flexibility. There's a cool little trick that we can see how many items there are inside an array if you do the following. Let me comment this out for a second. P array.length. So this is a new little trick. If you see when we say p array.length, when we print that out to the terminal, we get 7. The length of an array is how many items there are in the array. If I add more items to the array, so now there are 10 items to the array, array.length gives me 10. Okay? With this little trick, we can achieve the flexibility we want because I'm going to bring back my loop. Instead of saying 7.timesDo, I can make a new variable called number of loops and set that to be array.length, because the number of loops that I want to run are going to be as many items that there are in the array. And then instead of 7, I could say number of loops, which is just a variable for array.length, which in turn is the number of items in the array. We should print out the sum at the end. Okay, so this is sort of an earth-shattering concept. This is new. This concept of array.length, which returns, it gives me the number of items in the array. I set that to a variable called number of loops. And now instead of saying explicitly a number over here, 5.timesDo, 7.timesDo, 10.timesDo, I put in this variable, which changes based on how many numbers there are in the array. So now I can have an array that has just 5 items in it, and my loop will end up running 5 times. And I can have, I can have 11 items in the array, and my loop will run 11 times. So I've introduced this amazing level of flexibility that this code will effectively add up all the numbers from my array, no matter how many numbers there are in the array. Yeah, so Chris has a good question. We could, I did this to make it more explicit, but we could technically go right in here and say array.length.timesDo, and that would also, since array.length would give me, let's say 11 in this case, that would work as well. I decided to go this route to make it, in my head this is a little easier to understand, but Chris, you are correct. That would work too. Now to tie this all back to the original question is, I want to create a function that does this. Right? This is code that starts with an array and adds it up, and we're very, very close. But how do I build this into a machine that you can throw in the array as an input, and as the output, it returns the sum? So at this point, we're pretty much done. We're just going to build our adding machine again. It's going to accept an array input. Again, to demonstrate its usage, can everyone still see this in the back with the smaller font? Okay. To demonstrate how to use it, we would use it like this. We throw in an array as the input into this machine, into this function, right? So now, we basically put all this code into the function. We can't do this blindly, but we start with a sum of 0, start with the index of 0. We get the sum. We could say output is the sum and then return the output. And when we run this, it doesn't work because because here, right, let's read the error message. Error message on line 4, undefined local variable or method array. Did you mean array input? You even guessed what I meant. So on line 4, we say number of loops is array.length. Ruby says, I don't know what array is. And they're absolutely right. In our earlier version of this code, we had a variable called array, but we no longer do. What we do have instead is the array input. So I'm going to change this to array input, and I'm going to beat Ruby to the punch by changing that one too. And now, when we run it, it works. So when we throw in this array of the numbers 1 through 11, our function, our magical machine, adds up all the numbers and returns the output of 66, because that is the sum of all the numbers contained within the array. And again, it's super flexible. I can throw in a whole bunch of numbers. I'll throw in a negative number, and it will still work. So this is the beauty of a function a function that is a flexible machine. You can throw in any input, and it will perform a proper calculation no matter what, and return you the output with your desired result.